Hello listeners, my name is Pratika Avinash More, my roll number is 36 and today I am going to solve a transportation model using Row-minima method. So first of all let us see what is the transportation model. The transportation model is a special case of linear programming that deals with shipping a commodity from sources to destination, and the objective is to determine the shipping schedule that minimizes the total shipping cost while satisfying supply and demand limits. So basically, we have one industry that deals with supply and demand limits of particular city, and also that source of that industry, or we say city of that industry, also be in also considered. So how to solve row minima method? First, allocate as much as possible in lowest cost cell of the first row. Second, subtract the minimum value from supply SI and demand DJ. If the supply SI is 0, then cross that row, and if demand is DJ becomes 0, then cross that column. If minimum unit cost cell is not unique, then select the cell where maximum allocation can be possible. Repeat this process for uncrossed rows and columns until all supply and demand values are 0. So here we have a transportation matrix. So we have destination D1, D2, D3, D4, sources S1, S2, S3, and demand of that destinations are 5, 8, 7, 14, and supply from sources are 7, 9, 18. So we solve this problem by using row minimum method. So first of all, find the minimum element from the first row. So here is it is 10. So for 10 the supply is 7 and the demand is 14. So we can allocate it as 7. Then supply becomes 0 and demand remains 7. Now the here we can say the supply is become 0, then we we draw the strike between that row. Then come to the second row. Here it is the minimum value is 30. So for 30 supply is 9 and demand is 8. So for fulfilling his demand, we maximum can give him 8. So for 30 the allocation is 8. Now the demand becomes 0 and supply becomes remains 1. Okay, now we can see the demand we have 1 0, so we draw a line between that column. For we draw a line for the we know that to know that which demand or which supplies get fulfilled, and which destinations need to be destinations and sources need to be solved. So the row is still not get cancelled. So we see the next minimum element. So next minimum element is 40. For 40 the demand is 7, supply is 1, so can maximum fulfill its demand by 1. So the row becomes 0, 1 becomes 0, and 7 becomes 6. So you can see here it is 0, so we draw the horizontal line throughout that row. Now we have one row remaining, and the minimum element from that row is 20. Minimum element is 20. Supply is 18 and the demand is 7, so we can fulfill its demand by 7. Now the demand becomes 0 and supply becomes 11. 11. Okay. Now we can see the demand is fulfilled, so we draw the vertical line throughout that column. Now we have still the row will not get cancelled, so we look for next minimum limit, which is 40. Sorry for that. For allocation of that 40, we have supply of 11 and demand of 5. So we maximum fulfill is demand by 5. So 5 becomes 0 and 11 becomes 6. Now we have one element remaining, which is 70. For 70 we have supply of 6 and demand of 6, so maximum possible we can fulfill is demand by 6. Then we can see supply becomes 0 now and demand also becomes 0. Now the all rows get striked by horizontal lines. Now our problem is solved. Now we have to calculate minimum value by using that allocation. So for the our final, let's say, answer, our final answer is, we can see 10. The element cost 10 with allocation of 7. Allocation of 7 means 10 into 7, 70. You can do multiplication on that elements. Plus the next allocation is 8 with a cost of 30, means 30 into 8 to 40. Plus next allocation 40 with 1, means 40 into 1, 40. Plus next allocation 40 into 5, 200. Plus 70 into 6, 420. Plus 20 into 7, 140. So it's equal to 0. Then 7 plus 4, 11 plus 4, 15 plus 2, 17 plus 4, 21. 1. Then 2 plus 2, 4 plus 4, 8, 9 and 2, 11. So 1110 is our final answer. Thank you for listening my video. Also check out my other videos and subscribe to the channel.